Water. Science!
Water basins, magma, drinking water slopes. Science, oceans have dissolved salt with a higher content. The science lads.
Oceans. We've all seen them. But you may think that they don't affect your life. Well, the truth is that they affect everyone's lives. They provide us with many necessary things, such as food, gas, oil, and minerals. It's also the way most exotic foods are transported, and we can use it for recreation.
The ocean is never still. It's constantly moving and changing through its waves and tides. There are slow-flowing rivers at the surface of the ocean that carry large amounts of water across many kilometers. Muddy water can be found up to 1,000 kilometers from the coastline. There's also constant movement below the ocean surface. Even though there are many different seas and oceans, they are all connected. Oceans cover about 2/3 of the Earth's surface. Earth should have really been called ocean.
Ocean water differs from fresh water because ocean water has a higher salt content. So much, in fact, that the concentration of sodium in seawater is 16,000 times greater than in fresh water. 1,000 grams of seawater has 35 grams of dissolved salts. That's 35 parts per thousand, also known as ppb. The amount of salt dissolved in water is called salinity. The most common material found in the oceans is chloride, but it can also be composed of sulfates, magnesium, calcium, and potassium.
Nadine and Lily's mediocre science show.
In our experiment, we will be testing how salt water is much more dense than fresh water.
You will need a jug of fresh water,
Some ice,
food coloring,
some salt.
and something to mix with.
We will start by filling the freshwater cup 3/4 of the way.
And now we'll add some ice cubes. And after that, we're going to add some food coloring.
As you can see in our cup, you can see that the food dye is going all the way to the bottom.
And now we're going to do the saltwater cup. So you're also going to want to fill this cup 3/4 of the way.
And now we're going to add some salt, about a 1/2 cup. That's a lot of salt.
Then you can also mix it up. Mix it up so that all the salt is evenly dissolved.
It looks like milk.
It does. And then add some more ice cubes.
Okay.
Then add your food coloring. See how this time the food coloring is only staying at the top of the cup and not sinking all the way down. This is because the water is much more dense than the food coloring, causing it to stay upwards.
Fresh water, salt water.
Science. Why, hello there. Did you know that most of the salt that is found in the oceans originally came from rocks that were on land? Rivers and groundwater that would flow over the rocks would pick up the salt. The constant motion of the seawater mixes in the salt. Another source of chemicals in the water is volcanoes. Eruptions add chlorine and sulfur to the water. Eruptions that are on land instead of underwater can still add sulfur and chlorine. When they erupt, the materials can evaporate, precipitate, and then collect in the Earth's oceans.
Journey on the ocean floor. Features in the ocean basins are much bigger than on land, such as mountain ranges, steep valleys, and vast plains. Since there are no winds, rivers, rain, or ice to erode or carve the rock, the origins and formation of ocean basins are due to the tectonic plates. Long undersea mountain chains also known as ocean ridges, are formed by volcanic eruptions. Molten lava will flow out of these ridges and harden into new plate that pushes tectonic plates farther apart. Ocean ridges are more than 1,000 kilometers wide.
Along margins in the floor, trenches formed where the edge of an oceanic plate pushed against the edge of a continental plate. As the plates move together, they bend down beneath the heavier continental plate. Most trenches occur on the margin of the Pacific Ocean. The deepest trench is the Marianas Trench, not the band, and it goes 11 kilometers down. Besides the mountains and valleys, the ocean floor is quite flat. The wide open features of the deep sea are called abyssal plains, which are formed by thick deposits of sediment which comes from the continents. These sediments reach the deep sea by earthquakes and gravity, sometimes massive volumes of mud and sand sunk down at the edge of the continents, dropping to deeper waters. Mud-filled currents spread evenly over the abyssal plains.
Continental shelf and slope. Ocean basins begin many kilometers out at sea. The area between the coast and the edge is a submerged thing called the continental shelf. The narrowest continental shelves occur along coastlines, with high mountains where plates are usually moving together. The width of these is usually less than 30 kilometers. Along other coastlines, it is much wider, and it may extend 300 kilometers out into sea. From the edge to the shelf, the continental slope plunges at a steep angle to the floor. Continental slopes are usually less than 200 kilometers wide and 3 kilometers in length. Beyond the base of the continental lies the floor of the ocean basin.
Swimming away. Magma is underneath me, swimming anyway. Today is another day to find lakes flowing away. I'll be coming for your water, okay? Take on lakes, take on lakes, take lakes on, take on lakes, they'll be gone in a century or two.
Well, that's our show. Thanks for watching.
We hope you didn't cringe to death.
Okay,
Bye.
bye.